So then I'll begin. How to be a technologist in a climate emergency. This talk is online, and the transcripts for this is online at the Green Web Foundation BCS Insights 2021. If at any point I talk a little bit too quickly, or you want to follow up on any of the links and things that I've mentioned in the next 20 minutes. Okay. So, hello, my name is Chris. I am the co-director of the Green Web Foundation, a non-profit set up about 10 years ago to track the transition of the internet away from fossil fuels. And I'm also one of the organizing team of ClimateAction.tech, a community of technologists working on climate at various levels around the world. In the time I have with you, I'm going to introduce some terms which I found helpful when thinking about tech and climate. And then I'm going to talk about some levers we actually have as technologists that can help us rethink or think about our role in this. And then I'm going to come up with a kind of small summary so that you can take this with you for the rest of Insights. But first of all, let's start with climate emergency and climate response. We are in a climate emergency. Normally, when I do talks about climate and tech, it's common for me to start with a bunch of scary stats and photos to get across the idea that we need to act now. And if you're watching this, I figure you know that we need to act, but you might not know how many other people feel the same way as you now. There's a large and growing collection of democratically elected governing bodies who have declared climate emergencies now, from the local to the city level, but also at the national level, like the UK's Parliament a couple of years ago, and even at the supranational level, like the European Union. But what we tend not to talk about so much is why we are in a climate emergency. We are in this state because we haven't been able to find a way to get off fossil fuels as the basis for essentially providing energy for our society. As engineers, we tend to like to jump straight to solutions when faced with problems. So it's really important to think when talking about climate, to realize that effective action is about the need to take deliberate decisions, as well as thinking about how we can innovate our way out of a given predicament. And to give an idea of just how much the climate emergency is related to our inability to get off fossil fuels, it's useful to look at some data to help us understand it. What you're looking at here is information from the Open Climate Data website, showing more or less the same data that goes into the big IPCC reports that we sometimes see in the news when hearing about climate. And you see that big brown wedge? That's us burning fossil fuels. Each year, we emit around 35 gigatons of carbon dioxide into the sky. And because carbon dioxide in the atmosphere traps heat, it heats up our world and accelerates the process of global warming, or global heating, you might call. Even when we went into lockdown, it decreased, but not by very much. We might have decreased emissions by 2 to 3 gigatons. And you don't really need to be a scientist to realize that 35 minus 3 is not 0. Even during the COVID lockdown, it might have felt like there was a huge change taking place, but we were still putting CO2 into the atmosphere and making things even worse still. And if we want to avoid more of the damage that we're seeing in the news daily, we really need to reduce emissions. Every year we put off meaningful action, we make things harder for ourselves. This chart was made in 2017, but the general direction of travel is about the same. Just like a code base where we've been putting off paying down all that technical debt, we've done the same thing on a planetary scale. And now the scale and the rapidity of the changes we need to avoid the worst impacts of the climate crisis, it's leading to a new kind of language being used by scientists now. Now, we might need a bit more context for these words, and I'll try to summarize it quite quickly. Since the 1990s, representatives from almost every single country in the world have been meeting at a big conference called COP each year to figure out how to act meaningfully on climate together. And in 2015, after 21 goes at getting it right, we finally had a breakthrough, which you might have referred to as the Paris Agreement. One of the decisions made was that, yes, we really do need to act on climate, and we definitely need to cut emissions to make sure that we don't see more than 2 degrees of global warming. So while agreeing on 2 degrees is better than no agreement, a number of smaller island states basically said, well, this is fine, but we still drown at 2 degrees, and the human costs are still immense. What about 1.5 degrees? Globally, we commissioned scientists to see what the difference between 1.5 degrees and 2 degrees would be, and what kind of changes we would need to make this change globally. They released another massive report in 2018, and the short version from the scientists was, yes, 1.5 degrees is much, much less bad than 2. And 3 words were used in a message to policymakers to describe the changes we now need to make in the face of all the delay we've seen. Rapid, far-reaching, unprecedented. This language is important here, because if we're in a climate emergency, then talking about personal carbon footprints won't cut it anymore. When we talk about carbon footprints, we are usually talking about how to make them as small as possible before we go back to our normal lives. We don't need that, because it's not about one person or even one company anymore. It's about the entire system. And as the scientists say, it's about rapid, far-reaching, unprecedented changes now. In response to this state of emergency, I think we should talk much less about personal carbon footprints and instead talk more about climate response. It's no longer about getting back into eco-heaven or being personally free of eco-sin. It's about safety and avoiding harm. Climate emergencies require honking great, ambitious climate responses. And this is what we should be looking for from organizations and countries. So if you come along with me a lot and accept that we're in a climate emergency and we need to be thinking about ambitious climate responses, it's fair to ask what we can do as technologists. I think it's helpful to group the kinds of things we can do as technologists into 3 kinds of levers where our skills are applicable. Having these lets us at least see when we might be missing something obvious or think about stuff we might be doing anyway, but in a different light. Okay, so the levers. This is how I see it. I see consumption as a lever in terms of, can I change how much we need to do something? Intensity is, can I change how much we pollute when we do something? And direction, can I change where we are heading? I'll explain these in more detail now. As an engineer, we're taught to value efficiency and avoid waste. And this is probably one which is most intuitive to us. And to get a good example of this lever at play, it's useful to look at the internet itself and what it has enabled. And if you were to ask this question, what is the environmental impact of the tech sector? You'd get a wide range of replies. But because most of us have a hard time picturing what a gigaton of carbon emissions is, when I answer this question, I tend to talk in relative terms, comparing it to stuff that you might have heard of to help you build a mental model. For the purposes of this talk, you can think of the tech sector as having a carbon footprint of around 1 to 3% of global emissions. So this is in the same ballpark as the entire shipping industry, the entire aviation industry, the carbon footprint of Germany, or maybe even Canada. And once you have an idea of this footprint, it's useful to get an idea of what the kind of breakdown might be. So I found this chart from Ericsson's recent report on digital carbon footprints useful. You can see in this chart that making computers causes emissions, because remember, we need to melt sand before we can turn it into silicon chips to create microchips. And unsurprisingly, running computers also causes emissions because, well, we're using energy. Now, this chart also shows us that because networks and data centers are used 24/7, energy makes up a larger part of the footprint than for gadgets. And this means energy efficiency is a big lever here. In fact, energy efficiency has been one of the kind of success stories in computing over the last 10 years. Over the last 10 years, we've been able to benefit loads from valuable digital services, and use has exploded. But if you look at the total energy used by data centers and internet infrastructure, it hasn't really changed that much. Like, just imagine what this pandemic would have been like without all the digital services we currently rely on, for example. And if we look in more detail at these numbers, we see that this has been made possible largely by us switching and moving away from running code in relatively inefficient, smaller scale data centers with relatively low levels of utilization to running code in hyperscale cloud data centers which can be as much as, say, 10 times as efficient when running the same applications. Because they're also much larger, the providers can often afford to replace older, inefficient kits more quickly, making better use of Moore's law. And this has come at the cost of a much less diverse tech ecosystem. But from an energy use point of view, things could be worse. However, it's worth noting that Moore's law has been slowing down, and increasingly, the gains will need to come from further up to the top of the stack, where maybe software developers and software engineers might live, rather than trying to rely on the advances further down the stack at the hardware level. So this means, as a developer, understanding performance and efficiency is likely to become more important over time if you want to have a lever and control the total consumption. So that's consumption. But as Saul Griffith of Other Lab says, you can't efficiency your way to zero. So we need to think about how much what we're doing also pollutes. And I use this term intensity, and I'm going to focus on carbon for now, but this applies for other impacts as well. Again, let's use the internet because it's something we know, all right? Now, the best example I can think of for this would be the simple factor that while the internet is probably the biggest machine in the world, it's probably also the biggest fossil fuel powered machine in the world. And we might not see the impact directly, but when we talk about cloud computing, we tend not to think about burning coal or fossil gas, but we should. When we burn fossil fuels, there is avoidable harm being caused, not just through the carbon emissions that we mentioned before, but from air quality. New peer-reviewed research on the impact of air pollution from fossil fuels is actually really pretty sobering now, and it's stuff we're only learning this year. This pollution, for example, is responsible for 1 in 5 early deaths in 2018 globally. So this really is an issue that we need to address. But to be fair, it's not so much an internet problem as an entire energy system problem. And this here is a chart from the UK think tank Ember Climate showing how the global electricity mix has changed over the last 20 years. So we are seeing changes, and you can see this wedge in the middle of renewable energy growing. But given how late in the day it is, winning too slowly is the same as losing now. But there is some hope. Earlier in May, the International Energy Agency, which is an incredibly influential group in the power sector, they released this report about getting to net zero and 1.5 degrees. And they described what a climate response to stay within 1.5 degrees of warming would look like. Now, this is the first time such an influential body has shared a roadmap like this. And it shows that it's possible. But as the scientists say, the changes would have to be rapid, far-reaching, and unprecedented. We can decouple the harm caused by the underlying energy systems from digital services, but the only way we can really do this is to leave fossil fuels in the ground and in the past. So they explicitly say no more exploration of fossil fuels. Taking the place of fossil fuels would be a truly breathtaking amount of new renewable energy generation instead, more than 4 times as much as we have today. Like, it's not the only game in town. We would still have nukes and geothermal and maybe some hydrogen, but make no mistake, most of the work is being done by wind and solar. And I'll explain why, as it's related to a law that we're familiar with, Moore's law. Moore's law doesn't happen because computers magically get cheaper. They get cheaper because as we make more of something, we get better at making it. And this huge increase in scale is what changed the price of computer chips. And this increase in scale has changed the price of LCD screens and batteries. And we are relying on this law to basically scale for a transition away from fossil fuels. Now, this scaling effect is also something that tech firms have played an admirable role in, and it's another success story. What you see here is a chart from the IEA showing power purchase agreements where companies agree in advance to pay for all the power generated by a wind or solar farm so it can get built. These agreements are one of the most effective ways to get new wind and solar built and scale it up. And we can't really change the physics of climate change. What we can do is change the economics of climate change. And the blue bits represent efforts of tech companies like Google and Microsoft and so on to do this so far. They've been the biggest corporate players by a very, very long way. But it's not just US tech companies, though. The UK has been an absolute world leader in offshore wind now. About 10 years ago, the UK government made a deliberate decision to change the economics of offshore wind by scaling up its usage. They put out a massive tender to buy power at a fixed fair price for the next 15 years, but they used a special financial instrument called a contract for difference to encourage energy companies to compete to deliver the best bid and also to deal with the risk around working with such new technology. If the provider's costs were higher than the fixed price for power, the government would agree to pay the difference, reducing the risk for the company so they could take this bet. And if the company was able to deliver the power cheaper over the 15-year period, the provider would then pay back pay back into the public purse what it saved. And this was really, really successful. Rather than paying to subsidize private companies, the UK government is on track to have £600 million paid back to the taxpayer by 2027, as the cost of offshore wind has come down faster than anyone has thought possible. But it's not just huge tech firms and the UK government that is doing work to green the underlying grid we rely on. If you're in a tech company, you can do this stuff yourself now. And one company that I'm a fan of that's facilitating this is Ripple Energy, a UK-based tech startup that's now using the ability of the internet to coordinate finance, to allow crowdfunding and shared ownership of renewable energy resources at a much, much smaller scale. They make it possible now to buy a share of a wind turbine that has a name that you can point to on a map. And in return, you get lower rates for the electricity you pay for, because you are now part owner of an energy asset, not just a regular ratepayer paying a bill. This model works with businesses too, and I find it so much more compelling than offsets, because if the emissions from your organization are coming from fossil fuels, it makes a lot more sense to address the underlying cause rather than try to put offsets somewhere which might not have that same link. So this is intensity and how we can change the intensity of the compute we might be using, for example. Now, direction. We've covered consumption and intensity. Direction is one we are less likely to have encountered, because a lot of the time, if you're a technologist, you might be more familiar with being rewarded for solving a problem rather than defining a problem. And I use direction here because many of the problems we associate with technology, I would argue, come from us not really thinking through the consequences of going down a particular road, or they might be cases where people are not in a part of the conversation who should be in the conversation, or in some cases, we're just not questioning how we got to where we were in the first place. And I find this quote really, really useful from Cade's DM. If you've ever used the Signal private messenger, you've seen some of Cade's work. But this quote, technology is a social, political, and environmental accelerant, I think is really, really helpful for this. An accelerant is a substance that takes whatever is already there and speeds it up. So certain enzymes are accelerant reactions, but you might also use it to describe how petrol, when thrown on a bonfire, is also an accelerant. Sure, it can be useful, but it's easy to cause harm when you mishandle it. And there is an expectation that you know this when you use it. The other reason I like it is that it emphasizes deliberate choices. If technology is an accelerant, it's worth being thoughtful about what we choose to accelerate and what direction we're headed in. And I spoke about climate emergencies before, and we saw how Ripple Energy are working to accelerate community ownership of renewables. But much of My Society's recent work on climate is about accelerating the process of civic engagement around climate at a local level, because that's where so much just needs to happen right now. The idea is wonderfully simple. They collect all the climate action plans for all the local councils they can find and make them really, really easily findable and searchable. This makes it trivially easy to search and see if your local council has a plan yet. But it also makes it really easy to see what other councils have one and compare them without having to learn how to use every single council site or to know where to look. I think it provides a useful first step in engaging as a member of society and to use the democratic structures that are already there rather than trying to reinvent new ones from scratch. Direction is also important because if you don't think about where you're headed, you can do things that you think are helping, but end up doing more harm than good. And you might have heard of the rebound effect or the Jevons Paradox, named after William Stanley Jevons, who first wrote about this in 1845. He noticed that every time steam engines were made more efficient, the total amount of coal use in absolute terms jumped because people found more new uses for them and used them more. You can see the same thing when we move from, say, 3G to 4G. It might be more efficient, but we use it more. Or the number of meetings we have on Zoom because they've become so much easier to arrange. And more concretely, you can see this effect in things like ride-sharing services. So when Uber and Lyft first came into the market, it was easy to see them as a sustainability win, as they could replace car ownership and take cars off the road. This sounds good, but this convenience has a double-edged sword. The total driven miles in many cities has increased, not decreased, causing more pollution. And in many cases, ride-sharing can end up displacing greener forms of transport in the city, like transit or cycling, because especially when they're subsidized with VC capital to make it more attractive price-wise than other options. So direction in this case refers to understanding the implications of going down a specific route, and if necessary, adjusting when you have a better idea of the consequences. But direction also applies to things like startup accelerators in the tech field as well. And ClimateAction.tech is a good example. ClimateAction.tech was set up earlier this year to take the model of an accelerator that typically cranks out investment-ready startups designed to raise VC funding, but instead it cranks out nonprofits with ideas that can be scaled by subsequent rounds of funding from impact investors or governments or other foundations. So instead of measuring impact in terms of, say, return on the initial fund, they measure impact in terms of policy changes delivered or carbon reductions through behavior change. And you see many of the same techniques that you would typically see in a tech startup, but the direction is different, and especially the outcomes are different too. So I think this is all I can fit in the time I have for you, but here's a quick summary. We're in a climate emergency. We really can't afford to delay anymore. It's fossil fuels. We need to fix this before we fix anything else. Climate response. Emergency responses for climate emergency. We need more of these and ambitious ones, and we need to talk about them. And finally, as a technologist, you have 3 levers to help think about the way you work and your contribution: consumption, intensity, and direction. And yeah, thank you for paying attention for these 20 minutes. These are my details. This is a community I help run, and this is the magazine that recently won an award all about climate tech that we make. And this talk is online with about a bajillion references for every single thing I've mentioned. So please do go there and you'll see a transcript. And I think, yeah, thanks.